Today we're going to be looking at compiling, modifying and flashing firmware on your System 76 Coreboot laptop. This process will only work on supported models such as the Serval WS, Gazelle, Data Pro, Lemur Pro, etc. You can find a full list of supported models on their GitHub repository. Link is in the description below. The number one reason why people do this is to modify the default fan curves. Let's start by looking at System 76's firmware open GitHub repository. This repository has documentation, scripts, and subcomponent repositories. First is Coreboot. Coreboot performs the hardware initialization when you first power on your machine. It configures the system components like the CPU and RAM. It then passes control to a different program. Once Coreboot has finished, then EDK2 takes over. EDK2 implements the UEFI standard. UEFI stands for Unified Extensible Firmware Interface and replaces the BIOS that we all used to use. EDK2 will load your Linux bootloader such as Grub and Systemd Boot, or the Windows bootloader. The third repository is EC, which stands for Embedded Controller. This repository has the tools needed to build and flash the firmware to your laptop. This is the main reason why I decided on getting a System 76 laptop. Open source firmware. The second reason is their repair policy. Let's get started. First we will clone the firmware open repository. Open a terminal and run git clone and the repository link. The link is in the description below for your copy and paste and pleasure. Change directory to firmware open. Let's have a look at the documentation. System 76 has made a script to download all the required dependencies. Very nice. We will now run the install deps.sh script. This will install the required build tools and download all the code to your system. This can take some time, so go make yourself a cup of coffee. This script has made it very easy to set up your environment to compile and flash the firmware. Well done, System 76. As you can see, there's a lot of code involved. If this is the first time you have installed Rust build tools, then you will need to execute source, your home directory, .cargo/env. This will make sure your shell has the required environment variables. We will now run the build command to make sure our environment works. Once we know everything is working, we can then make modifications. Run the build.sh script in the script directory followed by your laptop model. In my case, it's SERW13. We have built the image, which means everything is working. We can now move on to making some modifications. First, we need to find our laptop model configuration files. Go to EC, then Source, then Board, then System 76. Here are all the laptop models. Go to your laptop's directory. In my case, it's SERW13. We are looking for board.mk. Open the file in your favorite editor. Here are all the configuration values and the fan curves. I'm going to start by doubling the charge current for faster charging. The flag that needs to be changed is charger charge current. This value is in milliamps, so if I want 4 amps, then I will double it to 4096. Next is the fan curves. The curve is defined by a list of fan points. Fan points have two values, the first being the temperature and the second being the fan duty cycle. The duty cycle is a number between 0 and 100, 0 being off and 100 being full speed. There are two lists of fan points. The top one is for the CPU and the bottom one is for the GPU. I am going to add more points in the list so the fans come on more gradually. At 60 degrees, I want the fans to spin at 30%. At 68 degrees, I want the fans to spin at 35%. This is my completed fan curve. Now we are going to talk about board heat up and board cool down values. Board heat up is the time it takes to ramp up to full speed, and if it's set too high, then it can create a sudden transition from low speed to high speed. Board cooldown is the time it takes to move from high speed to low speed, and if it's too high, then the fans will stay on for longer after the laptop has already cooled down. 20 seconds is definitely too long. I have set my heat up to 7. This keeps the fans in check for short CPU spikes. The cooldown is set to 5. This brings the fans down a lot faster after a workout. I am now done with modifying the fan curves. Let's add a personal touch while we are here. I want to change the boot image. Let's search the code for bitmap files. This logo.bmp is the bitmap we're looking for. It's in the EDK subrepository. I'm going to use the image of the Tsar bomb. Very dramatic. Replace the logo.bmp file with your bitmap and we are done. Now we can compile the firmware again. We have a build error. Let's check our configuration. There it is. Let's remove it and try again.
A great success!
We are now ready to flash our newly compiled image. Run the flash script in the scripts directory followed by your laptop model. Now reboot the laptop. Let's go. Don't forget to plug in the power. Never flash a laptop without the charger plugged in. Let's reboot. You will see the System76 firmware updater. It will prompt you for an enter. This is a security feature by System76. It ensures that someone is physically present to perform this operation. It's doing the writing and verification to the flash chip. The laptop shuts down. Wait a little bit and then power it back on. It takes a long time for it to power back on. After each flash, Coreboot will need to run through procedures like training the RAM. Once this is done, it's cached for faster boot times in the future. There you have it, flashed with a custom fan curve and boot image. This process is made easy by the scripts and procedures put in place by System76. Very nice. I look forward to flashing future updates. Thanks for watching. I'll be making more hardcore tech videos around self-hosting and digital privacy.